Okay, so I guess I will get started. This is the last live session for this term. I actually switched out the topic because I realized I had a video on the topic I was going to do, so I'm going to do applications of linear inequalities instead. Basically, word problems for linear inequalities. So let's just review the symbols and then talk about what they mean, in English. So we've got the less than symbol, which really doesn't have any other meaning in English. Less than or equal to. But this can also, when you're translating and you're having word problems, can mean at most or no more than. So those are other phrases that indicate you're dealing with a less than or equal to. The greater than symbol can also be translated as exceeds or is more than. And then you've got the greater than or equal to, which can be at least or no less than. So it's important to really understand the difference between at least and more than, because that's a difference between a greater than and a greater than or equal to. You do want to understand that is no more than or at most includes parts where it's equal to. So it's, that can make a difference in your answers. And we always read these going left to right. So whatever, because we read left to right. So whatever is on the left is less than or is greater than whatever's on the right. So linear inequalities are like linear equations, but now you are solving an inequality. So instead of having an equal sign, you are solving something with one of these symbols, but you're still solving for x. And then a compound inequality, which can occur, is when you have two inequality symbols. And those are specifically when you're dealing with problems where you have between two things. And usually with between, we assume that both of them are less than signs. But depending on the wording, you could have combinations of both. So your goal or whatever when you're solving is you're either going to have something on the left or on the right here. Or it could, your setup is going to look something like this. So let's just start with translating English into what that would look like mathematically. And when you're doing translations like this, you have to really pay attention to the directions, because less than can be translated as subtraction or the less than symbol. It depends on if you're writing an equation or an inequality. So if the directions say equation, then it translates as subtraction. If the directions say inequality, then you're translating it as the less than symbol. So that's really important. So we've got Tasha's average test score, and then they're giving us the variable for that T. And then we have the word exceeded 90. So if something is exceeding, it is more than, it's above 90. And this is on the chart here. Exceeds is greater than. We're not including where it might be equal, because then it's not exceeding anymore. So this is a greater than situation. So you translate it left to right. So the test score, T, is greater than 90. The next one, the height of a cave H was no more than 2 feet. So no more than means it could be less than 2 feet, but it can also be equal 2 feet. It just means it's not above 2 feet. So it's less than or equal to. So we have H is less than or equal to 2. The temperature on the tennis court T was no less than 100 degrees. So it's not less than 100 degrees, which means it's 100 or higher. So this is a greater than or equal to, because it's not less. So the opposite of not being less is equal to or greater. So we're using T for temperature. It's greater than or equal to 100. And then the depth D of a pool was at most 10 feet. So at most could be equal to 10 feet, or could be less than 10 feet. So this is a less than or equal to. So D is less than or equal to 10. So this is just some practice of those phrases, and you can refer back to this chart, no less than, at least, it's more than, exceeds, at most, no more than. You can translate these. You have a chart to kind of help you with what symbol they are. So we do more than just write these inequalities. We want to solve them because we have questions that we want to answer. So when you're solving inequalities, you're solving these the same way you solve equations. We add or subtract on both sides, multiply or divide on both sides. There are two big differences. First is if you're multiplying or dividing by negative, the inequality kind of reverses. And then you want to make sure that your variable is on the left. Generally, we always want, I don't have that written down here, but we do want the variable always to be on the left, versus when you're solving, it doesn't, like an equation, it doesn't matter if it's on the left or the right. So inequalities, we do want the variable on the left. But if you have a compound inequality, which would be if you have something that's a between, then you've got like three pieces that you're working with. But we're not going to do any of those here. I'm just focusing on one piece, regular inequalities. So we'll start with this example. The average winter snowfall for Burlington, Vermont for December, January, and February is 18.7 inches per month. If Burlington received 22 inches of snow in December and 24 inches in January, how much snow is required in February to exceed the 3-month winter average? So to get above the average for 3 months. So let's think about, let's set that part up. We want to exceed, be more than the 3-month average. So that's 18.7. So I can at least put that part there, that it's going to be greater than 18.7. Now, on the left, we're comparing the average of the 3 months to this 18.7. So when you're thinking of inequalities, you're comparing things. So we're comparing the actual to the average. And so we want to know, we're comparing the actual average here versus the average for multiple years. The 18.7, that's from multiple years of data. But we want to know, okay, how much have we gotten this so far that when we take the average, it's going to be greater than 18.7. So when you're finding the average for things, you're adding them up and then you're dividing by how many things you've got. So we've got December, let's see, 22 inches in December and 24 inches in January. And then we are figuring out February, and the average is you take those and you are dividing by how many you're adding together. So we're adding 3 things together because we had 3 months. So we add them, divide by 3. So the average, the actual average, you find by adding up the 3 months, dividing by 3. And we want to know, once we find that average, is it greater than the 18.7 that is typical? And so then the question is, we don't know February. So how much would we have to get in February to be above average, essentially? That is what this is saying. So we're solving for F. So first thing, whenever you're solving with fractions, is you want to eliminate fractions. So you multiply both sides by the denominator. So we're going to multiply both sides by 3. And when you're multiplying by a positive number, you don't have to worry about changing the inequality or anything like that. So that gives us 22 plus 24 plus F is greater than, pulling out my calculator, 18.7 times 3, nope, I have to put subtraction, times 3, 56.1. Now we're solving for F. On the left, I can add my 22 and 24. So that is going to be 46. We have 46 plus F is greater than 56.1. And then we're going to subtract 46 from both sides because we want to get the F by itself. And so you have F is greater than, and then 56.1 minus 46 is 10.1. So the question, how much snow is required in February to exceed the 3-month winter average? F is February. February amount of snow has to be greater than 10.1 inches. So we need to have more than 10.1 inches. If you get 10.1 inches, you're going to be equal to the average. We want to exceed the average. Now, when you're giving your answer to something like this, you have to basically write it down in a sentence. You can't just say 10.1 because the question is equal to 10.1, more than 10.1, less than 10.1. You have to be clear about which direction. So we'd be writing it down. We would say more than 10.1 inches of snow in February is required to exceed average. So you have to write it as a sentence. You have to translate that inequality into a sentence so that we have direction. And we know more than, less than. You have to kind of give an idea. Is it more than just that number? That sort of thing. Okay, so here's an example that is relevant to everybody. So anybody who says you don't use algebra, very helpful in your current life. You can actually use it for calculating your grade and figuring out if you're going to pass or if you're going to get a certain amount. And you can do this calculation throughout the term or at the end of the term, however. So in this course in MA104, the grade weights follow the table below. So I've got this table. Discussions are 15%, Connect Math is 20%, quiz work is 45, exam work is 20. And Stephanie, me, if I was a student, I have the following scores. So you can see my scores here. Instead of listing the scores for every discussion, there is a column in the gradebook that gives you discussion average. So that's 69% that I have. We want to determine the minimum she needs for Connect Math in order to get an A. So I did not put my Connect Math. There is a Connect Math column with like an average of your scores there. That I left blank because that's what we're trying to figure out. We want to know, what do I need in that column to get an A? And then there are 6 quizzes. My scores were 84%, 75%, 78%, 65%, 32%, and 0. And then exam work, we have 2 exams, that's 86% and 71%. So we want to know, can I actually get an A in the class? What do I need to get an A on the homework? And then is it possible to do that? So this has a setup. So this is a very common setup where you're taking your weights, you're multiplying it by the average, you're adding those all together. So discussions are 15%. So 15% as a decimal is 0.15. Connect Math is 20%. So that's 0.1 or 0.20. Quiz average is 45. So that's 0.45. Exam average is 0.2, and then we want to know an A is 90% or higher. So is that greater than or equal to 90? And then we're going to solve for our unknown. So we need the averages. We already have the average of all the discussions. We're looking for the average of the Connect Math. So we need to find our average on the quizzes and the average on the exams. So we're given the individual scores. We need to find that average. So first, let's find the average quiz. So the average quiz score. So That is adding up all of your scores, dividing by how many you have. So there's 6 quiz scores, we're dividing by 6. So that's 84 plus 75 plus 78 plus 65 plus 32 plus 0. And yes, you do need to include that 0 score. And we are dividing by 6. So when you're doing this on your calculator, you either need to put parentheses on the top or hit enter first and then divide. So that's 334 divided by 6. And so that is 55 point, we'll just say 55.7. So the average out of all of those is a 55.7%. And that's low mainly because of the last two, the 32% and the 0%. So if those were higher, that would go up. Now we also need to find the average exam score. So there's only 2 exams, so that's 86 plus 71 divided by 2. So that's 157 divided by 2. We get 78.5. So the average on the exams is 78.5. So we've got discussion 69%. Quiz average is 55.7%. The average exam is 78.5%. Now, just based off of these numbers, an A is a 90. None of these are that high. I would think that it's unlikely to be able to get an A with these percentages, but we will do the math to see, because the weights matter. Things that are weighted more matter more. So quiz work matters more than like exam work or discussions because it has a higher weight. So because the quiz score is low, that's going to be the biggest hindrance here. But we will do the math to find out. So we've got 0.15 times our discussion. So that is 69%. The 0.20, and our connect math is what we don't know. So I'm going to call that X. 0.45 times the quiz average, 55.7. There we go. .20 times the exam average, which is 78.5. And then greater than or equal to 90, since 90 or higher is the A. So we're solving for X. Multiplication happens before adding, so we need to do all of our multiplications here. So 0.15 times 69. So that is 10.35. That's 0.20x plus 0.45 times 55.7. 25.065 plus 0.2 times 78.5 is 15.7 and greater than or equal to 90. So now we can add the like terms on the left. 10.35 plus 25.065 plus 15.7. So those all add up to 51.115. And then we have plus 0.20x is greater than or equal to 90. So now that we've added all of our like terms, we're going to solve for x. We want to keep x on the left. I need to move the 51.115 to the right. So I'm going to subtract 51.115 for both sides. So we have 0.20x is great. Oops. Make sure I have the greater than or equal to 90 minus 51.115. 38.885. So we're solving for x. I need to divide by 0.20. And if I'm dividing by a positive number, I do not have to flip any inequalities here. So I just need to do my division. X is greater than or equal to 2 divide 194.425. So these are percentages. So this is saying that I would need 194% on the Connect Math in order to get an A. Well, that is not possible. You can't have more than 100%. So going back to the question, the minimum, and the minimum is the lowest possible score. So that's why we can be greater than or equal to. The minimum needed would be this 194. And the answer is no, cannot be done. So the minimum Stephanie needs is 194%. This cannot be done. So you can do a calculation like this on your own with your own numbers. We do have a column listing your Connect Math. And we have a column with like your discussion. You would have to determine your quiz average and exam average yourself. But you can do a similar calculation and you can kind of play with hypotheticals. I could redo this calculation and say, okay, if I don't get a 90, what if I wanted to get an 80? All I would need to do is change this number from 90 to 80 and then redo the math. So I can just do that quickly on my calculator. That gives me 144%. So still not possible. So then I say, okay, well, can I get a 70? You know, you can do that, redo the calculation, 94%. So it is possible to get a 70 in the class as long as the Connect Math score is above 94.425%. So you can do this calculation to see, do you need to do more, you know, redo some of your Connect Math scores to get a higher score, you know, are there things that you were missing on the discussions? You know, are you missing a discussion or replies? Maybe you need to boost that score up. Do you have missing quiz work or exam work? You know, boost that score up. So you can use this to kind of determine where do you need to be, or even what do I need to get on the week 8 quiz in order to, you know, get a certain score. So it's pretty powerful. The solving linear inequalities, very, very helpful. Okay, so this is my last example. I think this is my last. Well, maybe I have one more after this, I think. Yeah. A wholesaler sells t-shirts to a surf shop at $8 per shirt. However, for large orders, the price per shirt is discounted by a percentage off the original price. Let X represent the number of shirts ordered. The corresponding discount is given in the table below. So if you have less than or equal to 24, you have 0 discount. Once you hit 25 shirts, up until you hit 49 shirts, it's 2%. 50 shirts to 99%, or 99 shirts is 4%, and so on. So we've got 2 questions here that we're answering. If the surf shop orders 50 shirts, compute the total cost. So 50 shirts is in this bracket right here. And so the discount is 4%. So when we are writing our equation here, we're thinking back to when we were learning how to write equations for discounts. So you have the total basically, and then you would be multiplying by 1 minus whatever that discount is. So the discount, and then that gives you, you know, whatever you have. So our total here is we have 50 shirts and it's $8 per shirt. So 50 times 8 would be the total that would cost. And then we're multiplying 1 by the discount is a 4% discount, and we always subtract. We do the decimal version, so 4% would be 0.04. So that is our formula to basically compute the total cost. So 50 times 8 is 400. So we have 400, and then I can do 1 minus 0.04, which is 0.96. And then I can multiply those together, 384. So the total cost for 50 shirts is 384. So this doesn't involve an inequality at all. We're just finding how much does this equal. We're just using our discount formula. And we did have to do a little bit of extra work because we needed to find the total for 50 shirts, not just, for one shirt and do the $8. And then we got that discount. So the total cost would be 384. Now, the second question says, which costs more? 148 shirts or 150 shirts? Explain your answer. So the way that there are two ways that we can kind of do this one. We can compute them separately, do 148 shirts, 150 shirts, and then just say which one is bigger. Or you can set up an inequality and say, I think this one is bigger than this, and then you see if it's true or false. But I recommend just doing them separately. We still have to work with inequalities here because we've got this table that we have to read. So I'm going to kind of color code these. The 100 and, make sure I'm in my highlighter. So 148 shirts, that falls into this bucket with a 6% discount. And then 150 shirts falls into the next bucket with an 8% discount. So we have different discounts going on here. So let's first do 148 shirts. And that has a 6% discount. So I'm just writing this down, based off of the table here. 148 is between 100 and 149. So it's the same formula that we just did for 50. You have a 148 shirts and it's $8 per shirt. And then you multiply 1 minus the discount, which in this case is 1 minus 0.06. So 148 times 8, 1184. And 1 minus 0.06 is 0.94. And then we multiply those together. And it's money. Money always has two decimal places. So that comes out to $1,112.96. So now the question is, if you buy two more shirts, is it worth it? Is that going to be cheaper with the discount? And this is real math that you have to do in real life, especially if you're like, if I get this much more, when I'm shopping, if you spend this much, you get like a 10% discount. You have to say, okay, if I add this much more to my cart, I get this discount. Am I still ending up paying more, or am I going to pay less? Or even with like free shipping, sometimes it's not worth paying more to get the free shipping. You have to kind of do the math like this. So we have 150 shirts, and that is an 8% discount. So we have 150 times $8 a shirt. That's 1 minus 0.08. So 150 times 8 is 1,200. 1 minus 0.08 is 0.92. And then I multiply those together. We get 1,104. So that is cheaper than the 1,112.96. So it is cheaper to buy 2 more shirts to get that additional discount. But maybe, if we were comparing other numbers, if it was like 3 shirts or, if you had to buy 3 more shirts or 4 more shirts, maybe the math doesn't work out that it's actually cheaper. This is really important if you're running a business to know, well, can I actually save a little bit of money? 2 extra shirts, not a big deal. So the question was, which costs more, 148 shirts or 150 shirts? Explain your answer. And so 148 shirts costs more. You would pay 1,112.96, which is more than the 1,104 it costs for 150 shirts. So when you're explaining your answer with something like an inequality, you want to have comparison words. You want to be very explicit. Don't just give the numbers. You need to explain what that means, show that you understand that this number is bigger than the other number, put in your explanation what numbers you're actually comparing. That way somebody doesn't have to go back and look back at your math. They just look at your, what you wrote here and they're like, okay, cool. They understand. Okay, so this is my final example here. Luke and Landon are both tutors. Luke charges $50 for an initial assessment and $25 per hour for each hour he tutors. Landon charges $100 for an initial assessment and then $20 per hour for tutoring. After how many hours of tutoring will Luke surpass Landon in earnings? So surpass means be more than. So you're not going to be equal. If you're equal, you're not surpassing someone. You needs to be more than. So we want to know when Luke is going to be greater than Landon. So that's how we're initially setting up the inequality. So on the left, we write an expression for how you would figure out Luke's, how he's getting paid. And then on the right, we would write what it is for Landon, and then you're solving for the number of hours. So Luke is $50, and that's a flat fee for the first time, and then it's $25 per hour. So I'm going to use H for hours. So $25 times each hour would give you the total per hour, the total amount of hours. That would tell you how much that costs. Landon is $100 for a flat rate, and then it's $20 per hour. So that's going to be 20 times the number of hours. So now we're just solving for the number of hours here. So we always want to have the variable on the left. So we want to have H on the left. So I have to move the 20H to the left side. So I'm going to subtract 20H from both sides. And I always move that first so that I know where my variable is ending up. So I have 50, and then 25 minus 20 is 5. So minus 5H is greater than 100. So now I'm going to move the 50, because now that I know that my variable's on the left, the number needs to be on the right. So I'm going to subtract 50 from both sides. So I have, that should be plus 5H. 20 minus 20, 25 minus 20 is a positive 5. So I have 5H is greater than, and then 100 minus 50 is 50. And so now I just need to divide both sides by 5. And when you're dividing by a positive, you do not need to reverse anything. And we get h is greater than 10. So after how many hours of tutoring will Luke surpass Landon in earnings? And that's going to be after 10 hours. And I have to say after 10 hours, I'm not going to say at 10 hours because it's greater than. So Luke will surpass Landon in earnings. And notice that I'm basically restating the question that we have after 10 hours. So it's not at 10 hours. 10 hours is not enough. It's after he's done 10 hours. So that would be like 11 hours. Even 10 and a half hours would work because that's greater than 10. You know, anything after 10 would work. So that is the linear inequalities, how they are actually very useful in real life. A lot in business, especially when you're doing comparisons and inequalities. Those go hand in hand. Very helpful for finding out, you know, trying to figure out what your grade might be at the end of the term and whether you need to increase certain areas of the course to try to do better. If you can, just very, very helpful all around. So algebra is very helpful. So if you have any questions, feel free to email me, and I hope you guys have a great weekend. Bye.